Hi everyone and welcome to The Networks. I'm Gareth Spence. Today's show is all about Wi-Fi 7. Now, if you're familiar with this technology, you'll know that it has the power to be truly transformative. From latency to throughput to reliability, it's leaps and bounds better than Wi-Fi 6 and Wi-Fi 6E. But how are these improvements possible and what does it mean for users? To help me unpack all this, I'm joined by Adtran's David LaCagnina and Michael Sumitra. Guys, welcome to the show. Michael, can you set the stage for our listeners by explaining what's driving this evolution in wireless technology?
Sure, Gareth. I think the first and most fundamental thing which is happening is we are now in the multi-gigabit era, which is really powered by XGS technology. Over 30% of service providers in the US and even in UK and Europe, they're offering multi-gigabit services powered by XGS, and it's anywhere between 2 to 8 gigabit services that we are seeing. So that's one factor that we are seeing. The other is, of course, on the demand side. More devices in the home, anywhere between 17 to 20 devices, connected devices inside the home, video streaming, and now 4K streaming. That's continuing to grow, and it's both on the downstream and upstream, especially with all the connected cameras that you have inside and outside the home. Online gaming is growing, and with that, there's the need for low latency is becoming absolutely important. And remote work continues to be a driver, but it's more transition more to hybrid work. And this is driving all the bandwidth demands inside the home. With all of this, you have Wi-Fi, which is how these devices need to connect. And Wi-Fi also has to evolve, not just to extend speeds into the home, but also to connect all of these devices and all the high bandwidth applications. And we see Wi-Fi 7 is that missing piece that can actually deliver that multi-gigabit experience throughout the home.
You mentioned that we're moving beyond just speed improvements. How is the Wi-Fi landscape changing seemingly fundamentally?
So, Gareth, there's really been an architectural shift from old legacy Wi-Fi 4 and Wi-Fi 5 technologies. These technologies focused mainly on delivering the highest speed or throughput to a single device or just a few devices in the home. That's not the case these days, where you have 20 plus devices in the home, or even at times in some homes there are 50 plus devices. So you need to have the right Wi-Fi architecture to be able to support all these devices and provide the right throughput to all these devices. So the modern era has now changed to a new approach that focuses not just on speeds, but network capacity to connect all devices. So it shifted from those higher speeds to a distributed Wi-Fi network, especially with mesh networks, which started with Wi-Fi 6, which in fact was called high efficiency Wi-Fi. Now Wi-Fi 7 takes it a step further by delivering that increased capacity for all those devices, greater coverage because you have devices not just in the home but even outside, and greater reliability. And of course, Wi-Fi 7 is also all about greater speeds. So it's actually the first multi-gigabit capable Wi-Fi technology.
David, let's dig deeper into Wi-Fi 7. What makes this a true multi-gigabit wireless technology?
Yeah, sure, Gareth. So Wi-Fi 7 is simply the Wi-Fi Alliance's marketing name for the underlying standard published by the IEEE called 802.11be, and it's called the extremely high throughput Wi-Fi standard. So we just keep getting faster naturally. That's one of the big things, of course, every Wi-Fi generation seems to come up with. Every stream now in Wi-Fi 7 is capable of achieving up to 2.9 gigabits. That's just a single chain. Of course, that's that theoretical best. That's your peak physical rate throughput, not your actual packet throughput. It has several innovations, 4 that are really key, most of the industry wants to highlight and share. Those are 4K or 4096 QAM modulation. We now have access to ultra-wide 320 megahertz channels in the 6 gigahertz band. We unlock a new innovation called multi-link operation, which is very exciting. And finally, the last of the four key physical layer innovations are MRUs and preamble puncturing. So it's really it is indeed the first Wi-Fi standard that can, in reality, deliver a multi-gigabit wireless experience. Before we could achieve gigabit in certain scenarios, especially in a lab or when you're very close client to access point. This is the first one that really pushes it out into the network and makes it a reality for more and more clients.
I'd like to look at these innovations in a little more detail. Can we start by talking about 4K QAM?
Yeah, absolutely. So QAM, simply quadrature amplitude modulation. So that's the method by which Wi-Fi encodes data. So we vary both the amplitude and phase of a carrier wave, and that just allows every symbol to represent multiple bits. And we have different orders of modulation. So 64 QAM, 256, 1024, and now 4096, or we'll just say 4K for short, which allows us to pack in more bits per symbol, which naturally means you're going to have increased throughput available to you. It's important to note, of course, that as your order of modulation increases, what you're looking at is a constellation of signal points, and you're packing them in closer and closer together. And what that in effect does is make the whole system more sensitive to noise, and so you need a higher signal-to-noise ratio in order to achieve those higher order modulations. So Wi-Fi, as it always has in this era, adapts the QAM level dynamically. It's constantly evaluating link quality, and it will reduce the order of modulation as the connection gets weaker, as the SNR is reduced. So you've effectively got a QAM is a trade-off between speed and reliability in that wireless medium. And each wireless generation, we over the years has packed in more and more data. So if you were to kind of go back a couple generations, Wi-Fi 5, the state of the art was a 256 QAM modulation. So that allowed us to pack in 8 bits per symbol. With Wi-Fi 6 came 1024 QAM, and that gives us 10 bits per symbol. And now we're at 4K or 4096 QAM, which allows us to pack in now 12 bits per symbol. So effectively, you can consider the jump from 1024 to 4096 QAM is effectively a 120% increase in higher throughput. Now, of course, again, as I mentioned, you need that high signal-to-noise ratio to actually run at those highest order modulations. So that 120% higher throughput is effectively at short range, just as the 1024 QAM in Wi-Fi 6 was only available at short range. And of course, what that means for the user is applications are just going to run that much better. So all the latest things that are so important to so many users, the high-resolution video streaming, so many people are engaging with and using AR and VR applications, as well as a high-density deployment where you've got a lot of APs or a good mesh system in place that allows clients to run at higher SNRs. Then you can take advantage of that 4K QAM and better throughput, as well as reduced airtime consumption, because any given transmission takes that much less time on air to transmit.
The 6 gigahertz band seems like it could be a real game changer. What's happening there?
Yeah, it's really probably the most exciting aspect of Wi-Fi 7, I think a lot of people would contend. So the 6 gigahertz band unlocks for the first time 320 megahertz wide channels. Maybe I'll just run down a quick history of the spectrum evolution. So we started way back in 1997 with the first 802.11 spec, and that was the 2.4 gig ISM band. It was only about 84 megahertz wide, so pretty narrow. Between 1999 and 2016, various regulatory bodies and standards added to 802.11, unlocking big chunks of the 5 gigahertz band. And then in 2020, we had our biggest spectrum event in the history of Wi-Fi. So Regulators around the world, beginning with the FCC in the United States, opened the 6 gigahertz band for unlicensed Wi-Fi use. So now in North America and many countries around the world, you've got this enormous chunk, really a 1.2 gigahertz wide band, just all of a sudden enabled for Wi-Fi. And so when this was announced and when this was opened up back in 2020, the actual state-of-the-art Wi-Fi standard back then was 802.11ax or Wi-Fi 6. So the Wi-Fi Alliance felt the need to create a term to help delineate products that were capable of leveraging this 6 gigahertz band, and that's where we see the term Wi-Fi 6E come into play. I think in hindsight, it got a little bit confusing for some folks in regards to what does that exactly mean. But the whole intent is to simply indicate a Wi-Fi 6E product is capable of using the 6 gigahertz band. Back then, the max channel bandwidth that was available in the standard of 802.11ax Wi-Fi 6 was 160 megahertz. Now with Wi-Fi 7, in 2023, the introduction of 802.11be or Wi-Fi 7 now expanded that channel bandwidth to this new ultra-wide channel, call it, which is 320 megahertz wide. So some of the key benefits that are so interesting to folks. Naturally, anybody can do the math. That's a doubling of the channel bandwidth that's available at every single device that can participate on that band. And so now the real multi-gig rates are unlocked that were only a dream on the previous bands. And of course, that frees up the other bands, the spectrum in the 2.4 and the 5 gigahertz for operations that are important to those sorts of applications. So for instance, 2.4 can now be strictly used for things like IoT devices who are lower power and need longer reach, but don't really require a high throughput. That's really the best use case for 2.4 in this era. And of course, 5 gigahertz still being kind of that catch-all for everything else, reliable, available in most regions and pretty much every client in the world. And now with the 6 gigahertz band, we have a big chunk of spectrum that's available for high bandwidth applications.
What about multi-link operation? What is it and how does it work?
Yeah, multi-link operation, MLO for short. That's another core feature in Wi-Fi 7. So that allows a Wi-Fi device to simultaneously transmit and receive across multiple frequency bands. So in previous Wi-Fi generations, you use a single band per connection. Now with MLO, you can aggregate multiple links at the MAC layer. And of course, that's going to naturally increase your throughput. It can reduce latency and can improve reliability. So it's effectively dynamically distributing traffic across links, across bands for load balancing, failover. You can really ensure you're going to have much better performance in a congested environment because you have access to multiple bands to choose for any given transmission at any given time. So it's really ideal for bandwidth-heavy applications, latency-sensitive applications where you don't want to be sitting around waiting for a transmit opportunity. You have 2 or 3 bands available to you for any given transmit opportunity. So that just increases your likelihood of not having to wait in a transmit queue. And so that really makes all those applications I mentioned earlier, as well as real-time collab, industrial IoT, high-density environments. It really makes the whole connection that much more reliable for users. One way I've heard it expressed is you can think of MLO as just simply adding extra lanes to your wireless highway, if you will. So that's going to increase your speed, of course. You're going to have smoother traffic flow, and the reliability is going to go up as well. So really a great feature.
I've also heard you mention multiple resource units and punchering. Can you walk me through those terms?
Yeah, so in Wi-Fi 7 was introduced multiple resource units, or MRU. That's simply letting a user allocate 2 or more OFDMA RUs or resource units that are non-contiguous within that same channel. So the idea is to allow a wireless station to receive or transmit data across a chunk of spectrum that can become fragmented due to interference. So if there's no interference, then you've got a nice, clean, contiguous block, but that's not always the case. And MRU is here now to address that. So you can think of the chief benefits as really you're going to have better utilization of your Wi-Fi spectrum. So you're going to be able to reclaim capacity in channels where previously interference or even legacy users could be occupying small sections of the band or a sub-band and then just making the entire band unusable. You're going to have better throughput in noisy or crowded environments because you're going to be able to avoid that interference or that noise. And then you're going to be able to reduce latency as well in a multi-user scenario. So you can serve one user with small RUs for you've got a nice dense environment with a bunch of users with varying needs, rather than everybody waiting for a big resource unit to free up. You can use small RUs, MRUs, which is there's actually MRU is broken up into two subsections, if you will, large and small. And the small MRUs are great for those dense environments where you've got a lot of users who are waiting or who would be waiting without the benefit of small MRUs. So freeing up more transmit opportunities effectively. And so you're really just patching together good spectrum chunks to keep speeds high in these real world environments where the channel conditions are generally imperfect. And so preamble puncturing and MRU in Wi-Fi 7 are they work hand in hand. They're related, but they solve slightly different parts of that fragmented spectrum issue that I mentioned. So preamble puncturing was actually first introduced in Wi-Fi 6 and 802.11ax. And that lets an AP disable specific subchannels that are 20 megahertz wide within a wider channel, say a 40 or an 80 or 160 megahertz wide channel, breaks that up or disables it before transmission whenever those subchannels are unusable. The preamble is, of course, the first part of a Wi-Fi frame where the channel usage is announced. Puncturing modifies the preamble to indicate which subchannels are actually going to carry data and which are going to be punctured or skipped. And that ties into MRU, where preamble puncturing is about removing those bad chunks from a contiguous channel allocation so you can still transmit over the rest of them. MRU is about assigning multiple good chunks, which again may be non-contiguous, to a single user using the OFDMA method. So in practice, MRU can be scheduled after preamble puncturing has defined which subchannels are available, which lets the AP give a client multiple resource units around those punctured portions. One of the ways I've heard it, again, summarized or simplified is this. Preamble puncturing is telling the Wi-Fi mark the potholes in the road and drive around them. And then MRU is saying take several clear road lanes at once, even if they're not side by side. I think that's helpful to kind of understand how they work hand in hand.
Michael, let's shift to the business side. What's the value proposition of Wi-Fi 7 for service providers?
We see it as 4 distinct advantages that Wi-Fi 7 offers. First is, of course, it enhances the customer experience. This is the first true multi-gigabit capable technology. So you actually are able to deliver a multi-gigabit experience throughout the home with mesh Wi-Fi 7. And obviously it complements your fiber, your 10 gigabit, and especially your 2 to 8 gigabit service rollouts. You're able to give that experience, faster download, smoother streaming, and greater capacity for all those devices which are there. A couple of things that truly stick in my mind are 6 gigahertz. This is a newer band, and new devices that actually can support the 6 gigahertz band. They have a clean band, fewer devices on that band, less interference, and so you have a better experience. David talked about MLO and MRU and puncturing, lots of technical terms, but in effect, they deliver a more reliable connection and a better connection as well, allowing you to switch between bands. For example, gamers, it lowers latency for them, and especially for video connections for remote workers, you get a more reliable connectivity. So that's the first thing. Second thing is Wi-Fi 7 actually opens up higher revenue opportunities. You're able to offer premium services, bundle it with those. You're able to target new high-value segments, gamers, remote work, or even, for example, content creators. You can look at new business models where you're able to bundle services or upsell some of these services, and you're able to expand into other segments. You're looking at small businesses or maker spaces or boutique stores where you're able to offer very high capacity and very reliable connectivity. Third thing is you're actually future-proofing your infrastructure. Wi-Fi 7 is not just for now, but it is for the future as well. It supports current AR, VR applications, but any other applications which are coming, and even AI-enabled applications, which seem to be dropping into almost every device that's coming into the home. It prepares you for smart cities and smart communities as well. So that's one part of it, and service providers should look at it as really a long-term investment. I kept talking about customer experience. So that obviously has an impact on your operations. Better experience leads to better operational efficiency. With Wi-Fi 7, you have higher bandwidth, but features like MLO, 6 gigahertz, MRU puncturing, they deliver a better experience. So when you have a better experience, you have fewer customer complaints and support calls. And that leads to lower operational costs, allows you to invest that into your the savings into your network expansion.
Michael, how is Adtran positioned to help service providers seize this opportunity?
So Gareth, let's step back a bit and talk about the technology, network technology itself. Adtran is a global leader in 10 gigabit and XGS-PON. And early on, we recognized that Wi-Fi 7 was an ideal complement to XGS-PON. Wi-Fi 7 helps you monetize XGS-PON. And so we were among the first to introduce carrier-class Wi-Fi 7 gateways in 2024. And now we offer for service providers one of the largest and growing portfolio of indoor, ceiling mount, and outdoor Wi-Fi 7 mesh SDGs. And I keep going back to customer experience. It's about delivering the multi-gigabit experience. And with Intellify, we offer a complete managed Wi-Fi solution. Intellify is, in fact, the first service provider-focused managed Wi-Fi solution. So service providers can offer an exceptional experience inside the home or business, and also have greater visibility into subscribers' usage of their services in order to troubleshoot or remotely fix the issues. When you have satisfied customers, this can lead to new revenue opportunities. And we see Wi-Fi 7 as a high-capacity, highly reliable network, allows service providers to go beyond delivering connectivity to enabling high-value services such as parental controls or cybersecurity, new use cases in small businesses or MDUs or smart communities. And Adtran now has the right portfolio to help service providers unlock that new smart home opportunities.
David, can you tell me about Adtran's specific Wi-Fi 7 product lines?
Sure, Gareth. We start out with the 8700 series, a residential 10 gig Wi-Fi 7 gateway or service delivery gateway. These are true 10G class platforms, so 10G WAN, 10G LAN. We, of course, have 6 gigahertz and 320 megahertz channel support. We support multi-link operation, so that's how we get the lower latency, the improved reliability, and higher throughput per client. That really unlocks true 10G Wi-Fi capability. So not just multi-gig, but true 10G when you add up 5G and 6G together, just those two bands themselves. You're going to get great coverage on all three of those bands due to our advanced antenna design and layout. Operators will be able to make use of their cloud management portfolio that Adtran offers through Intellify. Plume is an option. You can manage through TR69, the legacy protocol, or the new TR369 protocol. That same capability is now being extended to the 9000 series that we've recently launched. The 9000 series is intended to address the convergence of small business and home requirements in the Wi-Fi space. So these consist of Wi-Fi 7 access points and a new 10 gigabit PoE router called the 9000. So we offer that 9000 as the hub, if you will, the router to manage all the remote PoE powered access points in a business or residence. And those are intended to connect to our indoor and outdoor Wi-Fi 7 access points, the 9732i for indoor and the 97120 for outdoor. All of these SDGs offer our entire suite of advanced security features and cloud management capability.
Looking ahead, how do you see Wi-Fi 7 evolving the connectivity landscape?
Yeah, it's really been a shift. We've gone from Wi-Fi as a good enough kind of technology to working to achieve equivalency with wireline technology. So we finally, with Wi-Fi 7, have something that can compete with wired connections, not just on speed, but more importantly on latency and reliability. You have wire-like performance now available in Wi-Fi 7 through all the new features we mentioned and spoke about briefly earlier. So all kinds of new applications that haven't even been imagined yet are going to begin to take shape due to the benefits of Wi-Fi 7 that before required a wire, but now can be accomplished without. And of course, service provider value propositions are transforming before our eyes. And they have been for a good while, but now more than ever, it seems like it's picking up pace. It's really accelerating. So gone are the days of considering simply basic connectivity as your proposition to a subscriber. They've really transitioned. Most of the operators have or are transitioning to delivering a premium experience. And so Adtran is spending a great deal of effort to enable operators to deliver those premium experiences and find new revenue streams beyond just the fat pipe of traditional broadband, and hopefully allowing operators to really find differentiation in an increasingly competitive market.
Michael, what advice would you give to service providers considering Wi-Fi 7 deployments?
Service providers need to really start planning strategically for incorporating Wi-Fi 7 into their multi-gigabit roadmap, tying it with their multi-gigabit service plans, then actually trying to identify their target segments, some of those segments that we outlined here, and actually planning out how to bundle and how to package all these premium service offerings and offer it to their target segments. Secondly, I think they need to think beyond just the technology. It's ultimately about how you deliver a better experience, and that becomes your competitive differentiation. And also, it enables you new revenue streams. So think about customer experience, cloud management, and we offer Intellify, cloud management platform, which truly is where your differentiation happens and opens up new revenue streams as well. Wi-Fi 7, we are seeing that starting to grow in the market. It's not fully prevalent, but you actually, as you adopt Wi-Fi 7, it gives you a first mover advantage. So early adopters can capture those high value segments and be prepared to actually own this market.
David, any final thoughts for our listeners about Wi-Fi 7's impact?
Yeah, I think we're really at an inflection point for connectivity. Wi-Fi finally is matching wired performance. I mentioned that a moment ago. That really is going to form a foundation for the next several years or even decade of how digital experiences are shaped. So this is really a transformational technology. It's not just another increment in Wi-Fi capability. This is a fundamental change in what is possible to do wirelessly. So that's really enabling completely new business models. And again, if you are an early adopter, you're going to find a competitive advantage over those who are still stuck on previous generations. So I think that service providers that are willing to embrace Wi-Fi 7 now are going to be the ones who define, in large part, the future of connectivity.
And that's everything for today's show. If you'd like to know more about any of the topics we discussed, please reach out on our social media channels. Thanks for listening.